Hello, this is Karthik here, and I am the General Manager Marketing at PROTECH Progressive Technologies. And I'm here to explain you about our wireless and cloud-based intelligent building automation system. Through this system, we not only help our clients in monitoring and controlling all the utilities, but also help them in energy savings. A brief introduction about our company. The company got established in 1992 with in-house R&D and manufacturing of various quality products based on microprocessor systems. We are recognized as a pioneer in our field by our customers. Led by our CEO, Mr. Sunil Reddy, we have more than 30 years of experience in design, development, and manufacturing of microprocessor-based instruments and control systems. We are an ISO 9001:2015 certified company. A brief about our products. We are one of the largest suppliers of tire inflators, that is air and nitrogen inflators across the country. We have more than 60,000 plus installations with customer base, including majority of the fuel pumps of IOCL, BPCL, HPCL, SRL, Reliance Fuel, and Reliance Geo or pumps, and other workshops of Hero, Motocorp, then Honda Motors, Toyota, Maruti Suzuki, and many more. Then we have oil management systems, so where we have automated the entire lube dispensing system, where and lube oil is directly dispensed from the barrel instead of from your bottles and touched by manual hands. So every Toyota, Maruti, Hero, Ford, Hyundai, and other multi-brand workshop use our system. We are the first company in India to automate the entire oil dispensing system, sir. And last but not the least, we bearing tester. We are the first company in India to indigenize this bearing tester. So this is a tester which was used to check the bearing condition inside any industry, like your any industry. So every Indian Navy ship as well as Indian railway workshop use our equipment, and other industries such as paper, coal, steel plant, and chemical industries use our equipment, sir. But when it comes to traditional building, so we have multiple utilities such as HVAC, lighting, fire pump, restroom, energy management, water tank, DG, elevator, LPG, air compressor, etc. Now, managing all these utilities is a tedious task for the facility manager, as they are dependent on their facility person for on-off of that utilities, and as well as taking down on the readings. Now, any early switching on or delay in switching off consumes a lot of power, and also to determine the accuracy of the readings, it's a question mark. Now, when let me take an example of a building where a typical air conditioning, which consumes almost 60% of your energy consumption. So in a building earlier, before the pandemic times, it used to start at around 9 a.m. in the morning. The pre-cooling used to start at around 8 a.m. at a fixed temperature of 24. Now, instead of doing that, if they can start the cooling at around 7 a.m., start the air conditioning at 7 a.m. at a temperature of 28 degrees and reduce 1 degree every 30 minutes. That is 7 a.m. 28, 7:30, 27, 8 o'clock, 26, 8:30, 25, 9 a.m. 24. So this small step will have a similar effect of cooling, but this again will have them a lot of energy savings. Similarly, then your clogging of the filter, where if the filters is not cleaned properly, then you have low air displacement, which means the more amount of time it cool the area. The another complaint which we regularly face is on the issue of low cooling. So the supervisor, so the user, when complains about low cooling, the facility guy never tries to understand the reason behind the low cooling. They will come, they will reduce the temperature and go back. Now, until and unless the user again complains of high cooling, the temperature is not raised. But again, the small action can lead to a lot of energy consumption. Similarly, you have an energy meter mapping where energy meters data is noted. So again, it's noted every 12 hours or 24 hours, but that doesn't give you any idea regarding your consumption pattern. Then you have your water management, again, which is one of the neglected resources. There is no proper monitoring on the consumption parameter. A lot of water gets wasted. That's one of the things. Then it comes to your fire pump. Then again, your jockey pump runs time frequently, hydrant pressure not being maintained. Then your fire drill not being conducted properly, and then whereas your water in the fire water tank is being used for other purposes such as gardening, cleaning, etc. So considering all these issues, which requires precious human resources for monitoring and controlling, we have a solution where all controlling and monitoring is on a single platform. The system is designed in such a way that it's affordable. When I talk about affordability, even if it's a small office of 1,000 to 1,500 square feet, we can do it to even a multi-story building, to even a spread out campus. The second point being here is all our modules are smart and wireless. They are and being a smart and wireless system, it's easy to install. It's so easy. Let's say I have a 18 to 20 story building with a lot of air conditioning units, let's say some 40 to 50 HUs, 100 odd energy meters, then your corridor lighting control, outdoor lighting control, your water pump levels control, and pump control, and all. your fire tank monitoring, DG monitoring and all. So I can automate the entire building within 6 to 8 weeks, sir. Provided proper operation times and support is there, we can complete the entire installation in less than 2 months. And then wherever we have done the installation, the average energy saving is around 20%. And last but not the least, it's a cloud-based system. And please note, sir, we manufacture the complete our own hardware as well as the sensors which we provide. So as I proceed further into presentation, I will explain, sir. So now coming to the building automation part, so these are the limited a set of parameters which we have shown here. The list is exhaustive. So the HVAC temperature and timing control, lighting control, signage control, AHU filter monitoring, energy management, restroom monitoring, water tank level and control, DG monitoring, chiller monitoring, elevator control, and many more. So coming to the schematics, so what we do is when we do a complete, when we go to a building, we identify the details which we are required to monitor and control, and we do a complete site survey of the building, and based on that we determine the number of communication points. For example, like for each and every utility has its own wireless module. They capture the data and send the data wirelessly to the smart communication manager console and gateway. In short, the gateway which acts as a bridge between these wireless modules and the cloud. So what we do is when we do a complete survey, we divide the area into multiple parts, and each area is allocated a gateway. So the data gets received as the gateway and sent to the cloud through GSM communication. So like that, so this entire building is covered. And please note, sir, all our modules are edge computing modules. They where each and every module, controlling module, have the inbuilt understanding and controlling capability based on the parameters. Then let me highlight some couple of issues with the existing BMS system providers. First of all, any decision has to be taken at the project level itself. The solution is custom developed for each project, thus adding to the design cost. It's a wired system which requires complex networking deployment across the building, takes months or years to execute, complicated installation, old tech, expensive software and server charges, no data logging, no data analytics, and dependent on third-party solutions and expensive maintenance. In a nutshell, sir, you have to listen what they say and you have to take only what they provide. And in this due course, it provides very little energy savings. Now, coming to our system intelligent building automation system, our system is truly modular, which means the decision can be taken as per requirement and budget and can be truly expanded as per building requirements. For example, a building has around, let's say, some 60 AHUs. So depending on the budget, you can start with the monitoring and controlling of 20 AHUs, and as and when they complete, it will show the benefit by energy savings and improving the efficiency of the system. And then based on that, you can start working on the next phase. Similarly, then we have a standard modules for each utility, which facility for add-on sensors and modules as per the client requirement. This I will explain as we proceed further into the presentation. Then all our modules is based on wireless system, hence ease of deployment across the building. Takes days or weeks to complete the project. It's a simple and easy installation based on latest IoT technology. We provide robust and expensive online software and cloud charges. We provide current data logging every 10 minutes. We provide even faster data logging as now let me highlight some couple of milestones of our company. We started our automation journey in 2014 by providing diesel monitoring system or diesel tracking system for diesel generators for McDonald's. We were given 5 stores, or in one of the stores in Sulagiri, Tamil Nadu, we were able to identify a savings of rupees 1.25 lakh in a single month. In other stores, we were able to identify a savings of 30 to 40,000 rupees. Then McDonald's then gave us a solution for wanted a solution for the electrical meter monitoring, LPG flow meter, and temperature monitoring. We started receiving orders from McDonald's along with the previous requirement, along with the control of their exhaust and signage. Then they gave us a requirement for controlling the air conditioning system. Thus, development started for air conditioning modules, and we started receiving more orders from McDonald's. But initial system, being a wired system, used to take more than a week for complete installation of a store. So we moved on to a wireless system, which reduced the installation time period from a week to a single day. And with this as a foundation, in 2018, we started developing modules for buildings, bringing ease of installation without complex wiring across the building. And the prime focus was on retrofit buildings as well as other chain of retail stores. So then other set of orders were also received. In the meanwhile, we developed the following modules: energy mapping, cold room monitoring, HVAC, AHU chill water, DX cooling tower monitoring, fresh air control, etc. Then water tanker level monitoring, water tanker delivery monitoring, water flow monitoring, fire pump monitoring, status monitoring, machine runtime monitoring, air compressor monitoring, equipment on-off control, indoor quality monitoring, lighting control, UPS monitoring, and so we have currently more than 60 plus modules or different variants which are developed. And the installations include Trident Hotel Hyderabad, Kaveri Hospital Trichy, Apollo Hospitals Hyderabad, Cafe Coffee Day, Barbecue Nation, Amcorp Mall. The entire mall has around 140 HUs which are controlled by our equipment only. Then McDonald's, Gaudium School, Adyar Anandabhavan, Narayana Udyalaya, Nanjappa Hospitals, 315 workspaces, MGM Hospitals Chennai, Oberoi Group of Hotels, Ortho One, your Nandi Rota, Freshazo, 4 Point Sheraton, IOCL Mysore, Yes Bank, CBRE, Domino's, Rockwell Refrigeration, PRK Hospitals, Glenmark Pharma, Sun Pharma, Tata Westside, Tata Chroma, Tata Star Bazaar. They all use our system. And we have more than 2000 plus modules across the country. So why it's important? First of all, it's mandatory for every organization to reduce the cost, then reduce the risk of the increasing energy demand, and as well as it's a mandate for now every organization to reduce the carbon footprint. So we have a saying at PROTECH: if you cannot measure and analyze it, you cannot control it. You can. So coming to our system, it's based on web-based wireless sensors and control, can measure the utility wirelessly, has a low cost of installation, can be expanded as per the building requirements. So the system collects data and sends to the web server, receive instructions from the web control. The user can analyze the data, give further commands to control. So again, coming to our system applications again, HVAC, complete HVAC, then your automated lighting control, diesel generator monitoring, water tank level and flow monitor, pumps on off control, air compressor monitoring, equipment on off control, fire pump monitoring, status monitoring, cold room monitoring, chiller plant manager, cooling tower monitoring and control, restroom monitoring, and many more. The key features being remote controlling and monitoring of the entire facility. You can automatically take control of various operations. You can manage all the system, coordinate with various systems, provide a comfortable working environment in an efficient way, control, monitor, optimize the building service, reliable and cost effective, recording of the utility consumption, reporting analysis, allows for classic preset limit. So we provide solutions for MEP consultants, energy auditors, hotel consultants, pharma, hospital, and many more. Partially stock customers are McDonald's, Cafe Coffee Day, Swiggy, Starbucks, your Oberoi, Kaveri Hospitals, Ortho, Yes Bank, Maruti Suzuki, Narayana Udyalaya, your Apollo Hospitals, PRK Hospitals, Nanjappa Hospitals, MGM Hospitals, and many more. We have more than 2000 plus installations all across the country. And this is the award which was awarded to us in 2018 by McDonald's for the Best Innovation Solution Award. So coming to the HVAC, so any type of HVAC, so we have the following modules: HU package, HU chill water type, split window, VRF, we can control the dampers, chill monitor, chiller monitor, chiller pumps control, cooling tower monitor, cooling tower primary and secondary pump control. So here, this is the step. Let me highlight the features of our standard module, basic module for HVAC chill water based HU, where we can give an on-off command, know the on-off status of the HU, set the temperature, measure the retain air temperature, measure the supply air. This is to identify again the performance of the cooling coil. If it is 8 degrees or above, it means the AHU is working efficiently. Then your delta T, the chill water supply, chill water return, then filter delta pressure to monitor the clogging of the filter. With these parameters above, for temperature, based on the 4 temperature parameters, we control and we modulate the actuator as well as take the feedback. And then we have your VFD control, 0 to 10 volt VFD control, fire input status, trip status, and then like that. Now to this module, we have a provision for to add on multiple sensors, such as if a client requires, they want a CO2 monitoring system or a PM monitoring system, or they want to control the fresh air dampers and all, we can add on an additional module to it and connect it to it. As I proceed further into the presentation, I will highlight the key features through a pictorial representation of the module. Now, there are now cases in a building where existing BMS is working, that is limited to only on-off, but there is no way to control their chill water consumption. So for those scenarios, we have a module, we have a miniature version of this module where we can know the on-off status of the AHU, and then based on that, we'll measure the retain air temperature, measure the supply air, delta T of it, then measure the chill water supply, chill water return. With these 4 parameters, we regulate the actuator control between 0 to 10 volt DC and then actuator feedback. Now for a DX type systems, what we can do is we can give an on-off command, know the on-off status, set the temperature, measure the retain air temperature, measure the supply air, delta T of it, then monitor the filter as well as unit control as well as their compressor on-off control. Now coming to water management, sir. So here in water management, we can provide the real-time water tank levels and then link it with pump on-off pump control. That's it. That is like if the water level is reducing up to 20 degrees, we can give a command automatically. The system will give a command automatically for the pumps to switch on. And once it reaches 95% or 98%, depending on the set parameters which you provide in the system, it will switch off the pump automatically. Then we have a solution for water tanker delivery monitoring system. And then if you have an existing water meters which has a pulse output port, we can integrate those meters and provide water monitoring system, water consumption monitoring. This is a complete water table where we can identify and control the input water flow, output water flow across the buildings or to this STP, and what is how much are treated. We can have a complete data. So we have a solution for that. Now coming to the fire pump system, this is one of the most neglected part in any building, where we have seen cases where instead of the pumps being put at auto mode, they are being either switched off or in manual mode. So here what we have seen is like your jockey pump is frequently running, then the diesel fuel in the diesel pump is being consumed, is being getting pilfered by the supervisor or any other person. Then your fire drills are not getting done as per norms. So here what we have done is we have a system where we can check the status of the hydrant pump, sprinkler pump and jockey pump. We can monitor the each machine runtime, then monitor a diesel pump. In the diesel pump, we monitor the fuel level, that is current fuel level, what is the amount of fuel that is poured, what is fuel consumed during runtime, and the battery voltage. Then you monitor your line pressure and monitor your fire water tank level. And then this data is updated every 10 minutes. So when there is a fire drill, you can correlate with this data and determine whether the drill is being conducted as per norms or not, and through smart data analytics. Then we have a diesel generator monitoring system where we provide fuel level monitoring, that is fuel level, fuel filled, fuel consumed, generator on off status, and if it has an RS485 communication port, we can provide additional parameters. Then we have your switch control and status module, where this module can be used to control any machine such as your lighting, pumps, electrical kitchen equipment, elevators, escalators, exhaust fans, etc. Then your status model can provide you on-off status, trip status, auto manual status, any other status as per requirement. Then we provide for gated communities where we can control all your outdoor as well as your corridor lights. Then you monitor of your diesel generator, fire pump, and many more for an integration of the smart meters such as for your electrical, water as well as your gas. Now coming to the system component, on the left hand side you can see this is what we call a smart communication manager console with gateway. This has two antennas. One antenna is for to and fro communication between the modules and the gateway, and the another antenna is a smaller antenna which is a GSM communication antenna for to and fro communication between the gateway and the cloud. This gateway has two SIM card provision for two SIM cards, where one is a primary, other is a secondary, based on the network stability and all. Then this is the energy meter module. So if a client has existing energy meter, we can integrate with existing energy meter with RS485, we can integrate that. Else we need to provide a separate energy meter with required CT coil as well as the connecting cables and the enclosure for that. Then this is the fuel sensor module for diesel pump or DG. So this rod is custom manufactured based on the height of the tank. Then this is your temperature flow pressure module. Then this is the DX module, where on these two ports provision for to put sensor for supply air, return air, then your unit status, unit control, then your filter monitoring and external. These two are for IR based modules for controlling IR based units such as split and cassettes and towers. Now this model is being shown here is for the module for chill water AHU. So on the right hand side you have four ports in blue colors. This is for return air temperature, this is for supply air temperature, this is for chill water supply, chill water return. On the left hand side is for actuator control and feedback and VFD control. On the left hand side of it is a 4 status input ports. On the right hand side, two controlling ports, one for AHU on off, controlling ports for AHU on off, then for filter monitoring. Now to this white port here is the RS485 communication port, through which I can add additional sensors or modules such as your CO2 sensor or additional pressure sensor or duct damper control module, and or I can add it. And these are all the sensors which we manufacture. So please note, as mentioned earlier, we manufacture all our own hardware and sensors, and all our sensors are digitized at the source, so they do not require any kind of a frequent calibration every year. And our sensors are accurate up to, for example, temperature sensor accurate up to 0.1 degrees, RH is almost 1% accurate, and many more. Then other system component is the switch control module. This is the pump compressor cooling tower module, LPG consumption module for restaurants, a similar module for your oxygen as well as nitrogen consumption monitoring for hospitals and other pharma companies. So we have a wide variety of applications, hotels, retail outlet, restaurants, and many more. So let me take you to the dashboard. This is the live dashboard of one of our installations called Trident Hotel Hyderabad, where we have deployed complete energy meter mapping, AHU, air handling unit monitoring and controlling, LPG gas consumption monitoring, temperature monitoring, cold storage monitoring, water flow. So here in energy meter mapping, so they have Trident has 4 main meters, 2 for incoming transformers, 2 for DG. Apart from that, we have deployed some 30 odd sub meters, which are now covering the 99% of the entire hotel. And so the data which is shown here is the live consumption data of today. So you can see they can have the data. Then let me take you to the air handling part. So this is, so the area is divided into multiple areas. So P3 has 1 AHU, P6 has 6 AHUs, 5 AHUs, and T4 has 4 AHUs. So 3. So here we can see the set temperature, return air temperature, supply air, delta T, chill water supply, chill water return, actuator control, actuator level, current actuator level, filter pressure, as well as actuator feedback. Now let me take you to the simulation part. So once I select the simulation, so I can see the simulation like supply temperature, return air, filter pressure, chill water supply, chill water return, actuator level, and here the feedback and all I can get, sir. This is the data I can get. So this is for your simulation. Let me take you to the analytical graphs. In the analytical graphs, I have consumption parameters, reading parameters and all. So let me highlight the key features for consumption parameters. Let me take you to the main substation, main transformer. Since the building hearing is done on kVH, so we are highlighting the kVH. This please note. So this is the your consumption every data. So this is the hourly consumption data parameter. So as I proceed further, I can see my day quarter, how much of getting consumed every 6 hours. This is today's data, then to the complete week. Now let me take the data set from today to from 1st of March. So from here, so this is my hourly cumulative consumption data from 1st of March to 6th of April, and this is my daily consumption data, which is being shown here. And this is my day quarter to day quarter, day to day comparison. So this gives me a complete idea what is my how my consumption is happening and what days at what time and all. So this is regarding the data. So this is a week to week comparison, month on month comparison, and this is a total consumption from till date. This is regarding the consumption. If you want in don't want in graphs, if you want in readings, I select on click on data and I get all the data in numerical, including for all hourly data, day, quarter, weekly data and all. Now let me take you to the readings aspect. Let's say if I want to monitor my temperature reading at the chiller, not chiller, the AHU. So let's say, let me take Padma AHU, one AHU. So here you can see my actuator feedback. So you can see actuator feedback. I can get maximum value, minimum value, and average value. I can get. I can select more parameters such as what is my chill water supply temperature during this time period. And so you can see the average supply was maintained between at 10 degrees to 25 degrees. Maximum average is 13.4 on a day-to-day basis, 12 to 15, 12 to 15, and sometimes it increased to 16 to 22. So this I can need to understand why there is happening. So I can select on a particular date and get a complete data analysis for that. This is regarding the parameters. Then when since we have done all the energy meter mapping, so what we have shown here is supply versus utilization graph. So here this is today's data. So you can see almost chiller 1 has consumed 17.5%, chillers 2 has consumed 16%, overall 33. Then your data center 1.5, your HVAC another 3%, independent kitchen panel 2.3%, 2.13, 9.7 lighting panel, main kitchen panel 6.8, like that I can get. Now if I club it, like for example, AC is consuming 37%, guest rooms is 16, kitchen. So I can get a complete idea where my consumption is happening at what time. This is for today. I can just select the further data, like for example, let's say from 1st of April to till date, the graph gets updated automatically, and I will get an idea where my consumption is happening. For example, let's say chiller again, 18% and 19%, almost 37% is your chiller, and your HVAC is another consuming 2.5%. So almost 41% it is consuming. 39.6% is your air conditioning, sir. So this is regarding our presentation and dashboard. If we have any queries, please feel free to ask, sir.